Stress-free learning with
Nyam.
create a better tomorrow. You get the program. Hard work pays off, so come and put it in. No need to wait, let the lessons begin.
If you have purpose, you do not need an alarm clock to wake you up, because your dreams and ambitions will wake you wide awake. Boom. Okay, so today, what are we doing today? Today we'll be doing trig revision. Okay, so we'll be doing trig revision, things that you should already know that you did last year in grade 11, or even further down that you should still remember because you're going to need to use them this year. You could have learned them in grade 10. They expect you to remember that. They might not teach you this year, but they still remember you to remember all that stuff because that's going to be in your exam. So let's start. What we start with? We're starting with trig identities. So let's try things that, these ones are the basic ones, the trig identities that you already know. Trig identities. Okay, so what is the first trig identity that you should remember? It's the simple one that's equal to 1. So sine squared theta plus cos squared theta is equal to 1. That's the basic one that you should know. And the other one that you should know is tan theta is equal to sine theta over cos theta. So that's the second one. So this is the first trig identity. And this is the second one. Those are the basic ones that you should know, that you should remember, that should be in your memory. Those are things that should come to you as second nature, right? So what else? What's next? So write them down. Get your exam pad, get your pen, get your wherever you write. Get that and start writing it down. Because I don't want you to say, oh no, you didn't give us all the right stuff. There is it right there. Okay? Write it down. Okay, so next, let's look at special angles. Special angles. Okay, special angles. What are special angles? I'm pretty sure you remember what they are. It's the one with the 30-60 triangle and the 45 triangle, right? Let's start with the 45 triangle. My drawings might not be as perfect as you want them to be, but they still have the same meaning, right? So this one is the 45 special triangle, right? So this is 90, this is 45. Of course, that means that angle over there in the top is also 45. So what are the numbers? The numbers are, this is 1, and this is root 2, right? That's the 45 triangle, right? And then the 60, the 30-60 one looks like this. So this is what it looks like, 30-60. So 30 plus 60, 90 plus 90 is 180, which is the total of a triangle. You should know that. You should remember that. So what are the values on the side? So this on this side, it would be 1, 2, and then roots of 3. So that's basically what the special angles look like, right? So this is the 30-60 triangle. That's the 45 triangle. So just commit these to memory. In case you forget, you can test these out by, let's say, putting them in the calculator. But there's one way, if you put in the calculator 1 over root 2, right? If you rationalize that, it becomes root 2 over 2, which is what the calculator will give you. And if the question says, do not use a calculator, and you give them root 2 over 2, they know that you use the calculator, so they'll mark it wrong. So be careful. Be careful. 1 over root 2 is equal to root 2 over 2, right? So now what else do we want to look at? Well, we want to look at this. You should not forget this. Let me write it on this side. Don't forget. What is it that I'm saying that you mustn't forget? Is this thing over here. The most basic things that you learn. You should not forget it though. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4 over here. Right? So how does it go? It goes C, A, S, T. So cos, or however you remember it, however you've been taught to remember it. This is how I remember it. C, A, S, T. What does the A stand for? The A says all of all of the sines, angle, cos, tan, they're all positive in that first quadrant. In the second one, only sine is positive. And in the third one, only tan is positive. The fourth quadrant, only cos is positive. Right? So, what do we have now? If it was easy, 1, everybody would have it. 2, it wouldn't be worth it. We have here 360 minus theta, right? And this one here, you have 180 minus theta. And in this one, you have 180 plus theta, right? So we have, these are all the different things that you should remember about this. So this is 270, this is 0, this is 90, and that's 180, right? So you should remember this. What's important? These numbers, 180 minus theta. So 180 minus theta over there would result in a positive sine. Over here, a positive tan. Over there, a positive cos. Right? So let's go to another one. These are also other things that you should memorize. Let me write them over here at the bottom. You don't really need to know all of these that I'm about to write down. You only need to know one of them, and the other ones you will know. But let me write all of them first so that we have them down. So we have sine 90 plus theta. What does that become? It becomes cos theta. Alright? So if you are really curious and you want to know how you result in this, you can go and search in your maths textbook. You will find the proof of all of these things. So sine 90 plus theta results in cos theta, right? So let's say we say cos 90 plus theta, right? What does that result? It makes negative sine theta, right? So this one here becomes negative sine theta. Okay, let's look at the other one. Let's look at sine 90 minus theta. What does that result in? That results in cos theta. The last one, the cos 90 minus theta, it results in sine theta. What do you see here? Do you see a trend? Of course you do. You see a trend that when it's sine, it becomes a cos, right? When it's a cos, it becomes a sine. But the one that says cos 90 plus theta becomes a negative sine theta. That's the only one that changes signs. All the other ones just change to the other thing. So it becomes from sine to cos. From cos to negative sine, because this is 90 plus theta. That's the only time. So this one here is the only one that you need to really remember or memorize. Right? You need to know that one. All the other ones, it doesn't change signs. Okay? So now let's look at another one. Another thing that you should be remembering. Put an underline there and let's number them. 1, 2, 3. Oh, I forgot one, yeah. Okay, let's call that 2, 3, and this 4. Then we have 5 over here. Okay, 5. What is 5? 5 is it's your basic sine. Let me show you it's sine and cos and tan in a quadrant, in quadrants, in the different quadrants. So let me draw it like this. Right? So in this direction, in that direction, this is the direction of x, this is the direction of y. Right? So let me draw an example of what I'm talking about. So let's say that's my triangle, right? So if they say, what's the coordinate of this point here? The coordinate of that point is x and 0. Coordinate of that point there is x and y. Coordinate of this point here is y, 0 and y. So now they say find sine. What is the sine in this region of that triangle? How do I find sine? How do I find sine? Let's label the things first. So this is x, that is y, and this is r. Right? That's your adjacent. No, that is your hypotenuse. This is your adjacent and that's your opposite, right? So let's say find sine. Sine of, let's call this theta, right? Sine of theta would be equal to, remember sine is what? Opposite over hypotenuse. So it'll be y over r. So it will always be, no matter, even if the triangle is this side, it will be always y over r. For cos, what would cos be? I hope you're writing this down. What is cos? What would cos be? Cos would be, since cos is adjacent, right? Adjacent, which is x over r. So it will be x over r. No matter where the triangle is, it could be upside down in the negative quadrant, but it still will be x over r. And of course for tan, what would tan be? I mean, you could do a calculation and say sine theta over cos theta, and then you have y over r over x over r. But what you will find out is that the r's will cancel out. But also, you can also look at the graph. If you look on the graph, what is tan? Tan is adjacent over, tan is opposite over adjacent, right? So what is opposite? Opposite is y over adjacent, which is x. So it will be y over x, no matter where the triangle is. So that's basically all the rules that you should remember. Okay, so now let me do an example to show you what I'm talking about. Normally, because these type of things that most people struggle with. They say find sine or cos or something like that, where they say don't use a calculator. So that's what I'm about to do. So this is example 1, right? Example 1. Okay, so what does example 1 say? It says sine theta is equal to 6 over 7. Right? And then now it says, the question says determine what tan theta is. So we know what sine theta is equal to. It's equal to 6 over 7. Tan theta, we don't know. That's what we're looking for. But now the catch is, it says you can't use a calculator, right? So because if you could use a calculator, you would just find what theta is, and then once you have found that, then you just substitute into that, and then you know what tan is. But you can't do that because why? They said no calculators, right? So since there's no calculators, we know that we have to first draw a triangle. So let me draw my triangle. So what is sine? From the couple of rules that we did a little bit back, if you go back a little bit, you see the rule that says that sine is opposite, which is y over r, right? So that's basically what this 6 over 7 is telling you, right? So you have 6 over 7. So, another example is, let's say they give you sine theta is equal to 5. Just 5. A whole number 5. What do you do over here then? Since it's y over r, what is the r? The r is 1, because 5 over 1 is the same as 5. So it will be 5 over 1. So y would be 5 and r would be 1. But in this example, we're dealing with 6 over 7. So let's draw that on our graph. So 6 over 7. So y, you want to go y in the positive direction. 6. And then we want to go y upwards. So we went y upwards and r. It could have also been on this side here. It really doesn't matter. So now let's draw in our values. We know that y is 6. Right? What is r? R is 7. Do we know what x is? No, we do not. So let's write it as x, because we don't know what x is. Right? So now we want to find tan. So we have drawn our triangle, but we are missing something. We are missing a variable, which is x. For us to find what we're looking for, we have to find what the variable x is. So how do we do that? How do we find what the variable x is? What we do is we use Pythagoras. Yes, the dear old friend Pythagoras. So what do we do? How do we do Pythagoras for all those who have forgotten? The formula is x squared plus y squared is equal to r squared. That's the formula for Pythagoras. It usually is written as a squared plus b squared is equal to c squared. But in this format here, we'll write it as x squared plus y squared is equal to r squared. So what is x squared? We don't know. That's what we're looking for. Plus what is y? Y is 6. So it'll be 6 squared is equal to, what is r? R is 7. So it'll be 7 squared. So basically my answer, x is equal to, I mean, you should be able to solve this. You really should be able to solve. If you're struggling to solve for this,
work like it depends on you, but pray like it's not up to you. For all of you guys who are religious, I feel like you feel that one deeply.
you really need to go practice your algebra and all that stuff so that you're up to date, because these things should be straightforward to you. So I'll take the 6 onto the other side, the 6 squared. So it'll be 7 squared minus 6 squared, and then I'll take the square roots on both sides. So my answer should give me 13. So x is equal to 13. So let me write out what x is. X is equal to 13. That's what my calculation told me. It led me to x is equal to 13. So now what do I do? Now what does my question say? My question says, what is tan theta? So I haven't done anything yet. I haven't solved my question. Okay? So tan theta. So tan theta is equal to, what is tan theta equal to? What's one of the rules? The rule says that tan theta is opposite over adjacent. Opposite is what? Y. Over adjacent, which is x. So what is my y value? My y value is 6. What is my adjacent value? It's 13. So that is my final answer. And this is my final answer right here. And I get my full 2 or 3 marks that I want. So that's it. Okay, now I'll be doing another example, but this example is going to be a proof, right? Because while we on this topic of trig revision, we should do a proof, right? So what is the proof? My example that I'm going to be using, example 2, it says prove 1 over 1 minus sine theta plus 1 over 1 plus sine theta is equal to 2 over cos squared theta. So that's what I'm trying to prove. I'm trying to prove that this side is equal to that side. Even though right now it does not look the same, it is equal to each other. They are equal to each other, right? So what's my first step? I'll write left hand side is equal to, what is the left hand side equal to? I mean, do you know where your left hand side is? Maybe it's this side? It's your left hand, not mine. Mine is on the right. So anyways, let's go with it. Let's start 1 minus sine theta, right? Plus 1 over 1 plus sine theta. Right? So why do I use the left hand side? Because it's it seems like I can work with this. That side is much more complex and it looks more difficult for me to break that apart. Right? So left hand side, what can I do from here? From here, what I'll do is find the lowest common denominator, right? The lowest common denominator, what is it equal to? It's equal to 1 minus sine theta multiplied by 1 plus sine theta. So let me write that down. So the common denominator will be 1 minus sine theta times 1 plus sine theta, right? That's my common denominator. So now what's on top, what do I do? So I have to go through and multiply everything by this common denominator. So if I multiply this whole thing into this first term, what do I get? This will cancel with that, so I'll be remaining with 1 times 1 plus sine theta, right? Okay, plus, because there's a plus in between, it's a different term. Plus 1 times, okay, if I multiply this whole thing into that term, what do I have? The plus 1 plus sine theta, 1 plus sine theta will cross out, and what will I be remaining with? I'll be left with 1 minus sine theta, right? So that's what I have now. So let me simplify this. This looks a little complex, looks a little bit difficult, a little bit untidy. So let's simplify it, right? So what's the next step? I'll multiply the 1 inside the bracket, right? Is that really necessary? Yes. Let's multiply, because if the number was different, maybe you'd have thought it's a different question. No, it's the same thing, right? So multiply the one hand side. I have 1 plus sine theta plus 1 minus sine theta, right? It's just multiplying by 1. It doesn't change anything, right? Now at the bottom, I can expand what's at the bottom. I can use FOIL, right? So it'll be 1 plus sine theta minus sine theta minus sine squared theta, right? So that's what I have now after I have expanded it and used FOIL to get my answers. So now what can I do? Can you see something that I can cross out? I can see something I can cross out. So this and this will cross out. Why? Because sine theta minus sine theta gives me 0, right? At the bottom, what do I have? The same thing. Sine theta minus sine theta gives me 0. So what am I left with? Let me write what I'm left with in my equation. I'm left with 1 plus 1, right? 1 plus 1 over 1 minus sine squared theta. That's what I'm left with. But at the top it says 1 plus 1. I can solve that, right? So what is 1 plus 1? 1 plus 1 becomes 2 over 1 minus sine squared theta. Okay, now let me look at the top. How far similar am I to what's at the top? What's at the top? It says 2. I have 2. In the numerator, I have 2. Okay, so we're getting somewhere. But in the denominator, they have cos squared theta. I have 1 minus sine squared theta. What can I do? I'm stuck. I don't know what to do next. But wait, if you look at your identities, your trig identities that we looked at the beginning of trig, you realize that 1 can be converted into a trig identity. That trig identity is sine squared theta plus cos squared theta, right? So if I do that, 2 over sine squared theta plus cos squared theta minus sine squared theta, right? This is what I have, right? So I replace the 1. So if you look at it, sine squared theta minus sine squared theta gives me 0, right? So what do I add? What am I left with? 2 over cos squared theta. This is what I'm left with. Is that the same as the right hand side? Yes. So this is equal to the right hand side, which means that my answer is correct. And you get your $5 for free. Really, for free. There's nothing too complex about this. Which part is hard? Maybe finding the common denominator. But that's straightforward, right? So that's it. I hope you guys get it. I hope you go and practice. Because you don't get this stuff without practice. You have to practice. So that when you get into your exam paper, you have seen that question before. So you'll be like smiling on your own, right? So yeah. Boom. Okay.